Hello there. Welcome to a special final edition of Team Wall Insiders, where a group of 4 senior computer engineering students bring you the latest tea on what is inside your walls. Here they shall be discussing their latest creation called Project Waldo. To start us off is Mr. Komara.
Hi, this is Team 4 Wall Insiders, and this is Project Waldo. My name is Maurice Kamara. I am a senior computer engineer at Cal State Long Beach, and my role is to design the modules and also program the position tracking system.
My name is Anthony Lee. I am a senior computer engineering major at Cal State Long Beach, and my role for this project is to be in charge of the heat mapping algorithm to display on the client's device, and also work on the client application programming.
Hi, my name is Aiden Little. I am a 4th year computer engineering student here at California State University Long Beach. My role in this project is anything IoT related, so making sure our device stays connected to the network and it's sending any data to our database. So then Anthony can take that data and create his heat map and any other information that we need.
My name is Oscar Serrano, and I'm a senior computer engineering student at Cal State Long Beach. In my role, I will be working on the stud finder sensor and also the electronic assembly.
So for the project objectives, Project Waldo will be a small handheld device that allows one to scan the wall, then aggregates the data from the stud finder sensor to construct a heat map of the hidden studs underneath. The position of the device will be determined via a base station with a camera mounted on it that will use camera vision to track the motion of the wall scanner. A visual heat map will be displayed on the client's device. So the main goal of this project is to gather data regarding the layout of the hidden wooden studs of a wall without damaging the wall itself. In addition to that goal, we have some technical goals we want to achieve as well. The first is that the scanning accuracy and precision should be as high as possible.
Have you ever been drilling into your wall to hang up your favorite family photo and this happens to you? Yeah, I thought so. So the purpose of our project is to solve the problem of individuals working construction to receive data acquisition of walls without damaging current infrastructure of their home or whatever building they're working in. One example of damaging infrastructure is unintentionally putting holes in your wall where you don't want to, or leaving marks on your wall that will forever stay there to remind yourself that there is a stud or pipe or whatever there.
Secondly, the UI should be clean and usable. And third, the device should connect and stay connected during the entire duration of use.
So for the project objectives that we're trying to achieve for this project, this block diagram as shown here, it best represents the overall implementation of what we will be creating in an actual product that will be demonstrated at Senior Expo. There are 4 main modules: the stud finder itself, the base station, server, and the client application. Each of these modules will help us achieve our main goals and will be further explained later on in this video.
For our stud finder sensor module, we'll be using a Franklin Sensor M150 stud finder. We will also use the PCB board inside as it detects wooden studs and displayed on the onboard LEDs. We will also use it to probe and capture the data using the ESP32. The ESP32 will also connect to an MQTT network to send over sensor data from the inputs. We will also use an IMU, which will be used as a part of the position tracking system. This will also be battery powered and rechargeable. And overall, the parts will be a stud finder control board, an ESP32, a battery and a battery manager PCB, and an IMU.
So for the base station module, the main feature is to track the position of the sensor module, as well as take a picture of the wall to be used to overlay the data on top of when we generate the heat map. We will send the position data to the MQTT network for processing. So the base station module will comprise of a Raspberry Pi Zero W, which will run all the software, a Raspberry Pi camera, which will connect up to the Raspberry Pi Zero W. In addition to that, we will also be leveraging the OpenCV library in order to perform our camera vision and track the module. We will be using the ARUCO markers, which will be positioned on the module itself and what will be tracked by the computer vision. And then we'll also be using the library libmosquito, which will allow us to connect our software up to the MQTT network.
For our server and database connections, it will have multiple features ranging from sending the data to the database that we choose and allowing Anthony's client application to access the data to create his heat map. This database will be stored within a server for, like I said, for client application access, and it will have reliable and constant connection to the network and to server. In the event of a disconnect, the data will be saved locally onto an SD card so the user can access that data from a CSV file or however we format it. For the hardware side of this, we chose an ESP32 development board to take the data from the stud finder and send it to a broker and save it in a file both locally and within the database. This data will be sent via communication protocol called MQTT. This works by publishing to topics within a broker, which handles the topics at any subscriptions or publications to the topics.
So for the client application, which will be running on the user's computer, the main feature of this is to visualize the stud locations detected by the stud finder and visualize it in a form of a heat map. Now, this client application will grab positional data extracted from Aiden's MQTT server and process it in a form of a way that can be displayed on the heat map. Furthermore, for the heat map, there will be also an overlay of the wall that was scanned to better provide further understanding of where the detected studs are in relation to the actual wall itself. One feature that we are also thinking of implementing is to allow the user to export the overlay heat map as a photo for future references, such as in the form of a PNG file or a JPEG file.
In the future, if we have time, we would like to implement 3 stretch goals. The first stretch goal will be a laser base station, which will display lasers on the wall where the studs are. This will include a tripod station, a range distance sensor, some lasers, and some servo motors to change the angle rotation for the lasers. The second stretch goal will be an AC voltage tester. This will detect the presence of AC voltage when the sensor scans above it. The third stretch goal will be in adding the screen onto the device, which will also display the heat map onto the device instead of just having it onto the client's laptop.
At the start of the semester, we wanted to work with other engineering students to make a wall scanning robot. However, this fell apart when we realized there are different senior design professors had very different design requirements. The first change was to not use a robot at all. Instead, we would make a handheld device. This proved to be too difficult while working with the other students, and we could not make the design good while accommodating for the other students' requirements. Secondly, the second change was to disregard the other student projects and work on the project idea by ourselves. This would allow us to design our project completely by our own parameters without concern for intercompatibility with the other projects. Overall, this change allowed us to have a much clearer vision for the goal of our project and allowed us to return to an idea very similar to what we had originally planned, just without the robot.
For this project, we'll be using NASA's project lifecycle, and this project lifecycle uses phases. And in this semester, we have already completed phase A and B, which are just planning and finishing designs of what our project will be. And starting today to the end of next semester, we'll be starting phase C.1. This will finish final design of Waldo and prepare for fabrication. This will also continue prototyping code for each of the other modules. We will also finish building a test wall to test our stud finder. We will also print a module housing. For phase C.1, we'll be starting our fabrication of all the components and finishing programming of all the final code. We will probe the stud finder to input to the ESP32 and development of the database onto the server. And then for a final phase D, we will develop the IoT code on the server, verify the heat map to read the incoming sensors inputs, and then we'll also complete assembly of all the operations of Waldo, and we'll also test all the code that ensures that all the components work together.
So that outlines pretty much all of the stuff that we have planned for Project Waldo. Over this next semester, as we mentioned, we plan on actually building and getting it all set up. We also plan on constructing a mock wall that we can actually use to test the device in a real world scenario. And we expect to bring all of this stuff and set it all up in the Senior Design Expo next semester for everybody to see. So hope to see you guys there, and thank you very much.
Okay. Let's dance, baby!